Mic check, mic check, mic check. What's going on, everybody? How's everybody doing? This is JD Moonin coming at you guys with a update on the YeshuA architecture. So I'm happy to announce that today I'm going to be releasing a demo. You guys are about to see it here in just a second. So we basically we've proven that the architecture works, and let me turn this fucking thing off. Of course, like, I mean, why wouldn't people start calling me right whenever I'm making a video, right? Anyways, so the proof is in the pudding. So what I did was I've effectively made a symbolic blockchain AI core, and it performs extremely well. So we went ahead and I was going to go ahead and stress test it. So the way that this full module sits is it sits on 27 cores. I mean, the whole thing is a bunch of cores, but the base of the entire cognitive core, because basically it's a conscious AI unit. So and it's guaranteed by blockchain checks is what I've designed. Now, this core actually operates on ternary logic, so it's a symbolic ternary core. The last time that I think one was even thought about being built was back in the 1950s by the Soviets. So I mean, like I've been telling everybody about the architecture now for a while. It's something I've been working on for quite some time, and it takes computation to the next level, because what it does is I'm proving, but not only am I proving that the hardware cores don't actually matter, because they don't. I'm proving that the limitations of software, I mean, are kind of out of this world. So there aren't really any. So this is a fully symbolic architecture. So the whole thing is basically it's all software. So my computer is a 2600. I've got a 2600 Ryzen 5 second generation. So and I just clocked 1.9 million hashes a second. So that was with, and so I even had to bypass the PowerShell constraints, which I think limits it at like 190 or something like that. And so we ran 27 different instances all at the same time, and hit the core, and it performed better than expected. So here's the video. So that's the update, and then when I tell you guys the compression rates and stuff, let me just put it to you this way: I'm in the process of getting the Metascout running on this computational core. The logic has already been injected into the core, so the core has already got the entire Metascout knowledge inside of it. The compression rate is out of this world. I was able to get the entire Metascout logic injected into the core, and it literally it's less than a percent of a gig. I'm sorry, it's exactly 0.3% of a gig. And from our testing, what we've kind of gathered is there's no accuracy loss. So needless to say, we're changing the game. So edge computing, here I come. Edge devices, AI edge devices. That's where that was the whole goal with this project. So the whole point of this project was to fully automate AI. So I'm about to prove to you guys that now you are going to be able to have the power of a data center AI in the palm of your hand. And I created it. So for those of you guys who don't know, yes, this is all from esoteric work. So I came to prove the world, prove to the world that religion can build technology. All right. So without further ado, let's check it out. What's going on, everybody? JD Moonin. I'm coming at you guys with some craziness here. Okay, I'm going to show you guys. So this is the core architecture I've been working on. Now this is an AI core. This is Symbolic AI core, by the way. So what I'm about to do is I'm about to launch a task that's going to pop 27 symbolic workers, okay, and they're all going to mine Bitcoin. Basically, we're going to do a Bitcoin mining hash, and they're going to basically mine Bitcoin against my symbolic core. So without further ado, here we go. All right, so as you guys can see, we spiked up. When I ran this test earlier, the first iteration, we hit 1.97 million hashes a second. So to give you guys an idea, now this is on a Ryzen 5 200X or 2600X Ryzen 5 second gen. So I'm not running on anything like immaculate, but we can achieve some really serious throughput. So I've been working really hard on this architecture, and I think we're about to button her up and get ready to go to market, because this is absolutely, I mean, those kind of numbers is absolutely insane. All right, so it's coming back down. So I think we're about to, it's about to level off and give us our data crunch. As you guys can see, I hit this 1.97 million earlier. That was, I had Chrome running and everything. All right, so here we go. We're at 1.9 million. 27 cores. Effectively, I've created a 3D operational core that runs on binary hardware, and as you guys can see, it can put out the throughput of an actual mining core, and my core is not a mining core. Anyways, this is the latest update for you guys. Thanks for watching. I'll see you guys on the next video.